We will continue our work on cross products by looking at a couple of examples. So we have vector u given by 1, 0, negative 2, and vector v given by negative 5, 2, 4. So in part A, we're going to use the dot product to verify that u cross v and v cross u are both perpendicular to both u and v. So let's do u cross v. And we know that we're going to go I, J, K for the top row. And then since it's U first, it goes as the second row, 1, 0, negative 2. And V is going to be negative 5, 2, 4. So expanding along the first row, we're going to get I times its minor, which is 0, negative 2, 2, 4. And then minus J times its minor. And that's going to be 1, negative 2, negative 5, 4, and then plus k times its minor, which is 1, 0, negative 5, 2. And so expanding that, we're going to go 4 times 0 is 0, minus a negative 4 is going to make that a positive 4i. We're going to get minus, and then 4 minus 10 is going to be a negative 6. So the minus negative is going to make that be a plus 6j. And then we have 2 minus 0, so that's going to be a plus 2k. So this is our vector u cross v. Now we know that if we switch the order just from our properties of cross products, that v cross u is going to be the negative of u cross v. So that's going to make that be a negative 4i minus 6j minus 2k. And then we can show that their dot products to both u and v are going to have to be 0 if it's going to be perpendicular. So if we take the u cross v, so 4, 6, 2, and we dot that first with u, which is 1, 0, negative 2, we're going to get 4 times 1 is 4, and then 6 times 0 is 0, and 4 times negative 2 is negative 4, so that's 0. And then if we take the 4, 6, 2, and dot it with v, then that's going to be dotted with negative 5, 2, 4. And so we'll get 4 times negative 5 is negative 20, 6 times 4 is 12, 2 times 4 is 8, and sure enough that's equal to 0 as well. So if we look at v cross w and dot that with first u, then that's going to be v cross w is going to be the negative 4, negative 6, negative 2, dotted with u, which is the 1, 0, negative 2, and that's going to be negative 4 plus 0 plus 4 is 0, so that's has a dot product of 0, so we know that it's going to be perpendicular to u. And then if we take our negative 4, negative 6, negative 2, and dot that with v, which was the negative 5, 2, 4, then that's going to be 20, and I think a minus 12, and a minus 8, and sure enough, its dot product with each of them is 0. Now working on B, let me change the color of my pen here. And so in part B, we're going to find sine theta. So now we have a way of finding cosine theta using the dot product, because we know cosine theta is u dot v over magnitude u magnitude v. Now we have that the magnitude of u cross v, we said, is the magnitude of u times the magnitude of v times the sine of theta. So we have a way of directly getting to sine theta, because we could always use the dot product and figure out what the cosine theta is and then go roundabout that way. So what we're going to get, though, is that sine of theta directly is going to be the magnitude of u cross v divided by magnitude u and magnitude v. So u cross v, we said, was that 462. So its magnitude is going to be the square root of 4 squared is 16, 6 squared is 36, and 2 squared is 4. That's going to be over the magnitude of u, which is going to be the square root of 1 squared plus 0 squared plus 4 is the negative 2 squared, and the magnitude of v is going to be 25 plus 4 plus 16. So let's see, we've got the square root of 56 in the numerator. It's going to be the square root of 5 and the square root of 45 in the denominator. So let's see if we can simplify that a little bit. 56, I think, is 4 times 14, and we have square root of 5, and the square root of 45 is the square root of 5 times the square root of 9. So it looks like 2 square root of 14 on top. Square root of 5 times square root of 5 is 5. Square root of 9 is 3. So I think 15 on the bottom. So our exact value is going to be that the sine of theta is 2 square root of 14 over 15. And we could put that in our calculator and get a decimal if we like. But that's going to be good enough for our answer here. So I'm going to go to a new screen. I'm going to pause it for a minute and write out the next example. So in this example, we're going to try to find the area of triangle ABC given these 3 points in space. So if you remember, if we can find vector, say, AB, just going to give a little visual here, and vector maybe AC, then we know that from the magnitude of the cross product vector. So if we can find that cross product vector, AB cross BC, and get its magnitude, that would be the area of that whole parallelogram. So that would make the area of triangle ABC half of the parallelogram. So our area of that triangle ABC, we are going to take 1/2 the magnitude of vector AB crossed with vector AC. And the only thing that's special about AB and AC is they share the same initial point. You know, we could have done BA and BC or CA and CB. That should all give us the same thing. So we need first, what is vector AB? And we can see going tip minus tail, -2 from C minus 0 from A is going to be -2. 0 minus 1 is -1. -1 minus -3 is going to be +2. Vector AC is going to be -2 minus 0 is -2. I think I did that already. 0 minus 1, -1 minus, so that was actually AC that I just did. Sorry about that. So that's actually vector AC. Vector AB, if I do this one right, is going to be 2 minus 0 is +2. -2 minus 1 is -3. -9 minus -3 is a -6. Hopefully I got that right. So we are going to then find vector we can do, since I wrote it first, well, let's do AB crossed with AC. It doesn't matter. So AB crossed with AC is going to be, we'll go I, J, K for the first row. I'm going to do AB is the second row, 2, -3, -6. And AC is the last row, -2, -1, 2. We're going to use expansion by minors. So expanding along the first row, we're going to get I times its minor, -3, -6, -1, and 2, minus J times its minor, 2, -6, -2, 2, and then plus K times its minor, 2, -3, and -2, -1. So it looks like we're going to get -6 minus 6 times I and then minus j times, that's down 4 minus up 12, plus k times negative 2 minus 6. So that looks like a negative 12i and a plus 8j because of the negative there from the j, and a minus 8k. So there is our cross product vector. So our area now of our triangle is going to be 1/2 times the magnitude of that cross product vector. And so that's going to be 12 squared is 144, 8 squared is 64, another 8 squared is another 64. I think that's going to give us 272. And I think we can actually simplify that. I think that's actually 16 times 17, which is going to get us 4 square root of 17. That's the parallelogram. So we want to divide that by 2. I guess we should have said this was going to be divided by 2 all along. So that's going to make it 2 square root of 17. Very nice. See what you can do with homework 18.